So you've heard a number of interesting stories today, and one thing I want to share with you is when I joined AWS, it was about a year and a half ago, and I don't think a week has gone by where a customer or a potential customer has not said to me, when is Amazon going to have a region in Australia? And so it's been a long time I've been waiting to be able to say, well, as a matter of fact, we have one today. So I'm really thrilled that all of you can take the benefit of the new region and build that into your own architectures. Now, the topic of our talk today will be extending your data centre with AWS. And people often say, well, why would I want to do this? Why would I even want to think about this as an option, as a technology? So many organisations face a variety of different constraints. Some people face power constraints. There's either not enough power to the data centre in aggregate, or there's lack of density of power in certain areas. I've had customers where they've said, we're out of power, and we're so out of power that we can't replace the information or the equipment with new power because we can't take the old equipment out. So I can't put more efficient equipment into the system, into the environment, without taking the old stuff out, but I have no capacity to do so. So I'm kind of stuck. So I need a different option. For many people, there are space constraints. Space constraints can be inherently inelastic, as we've talked a lot about today. And I was working with a bank once, and they had a tape silo. These big tape silos, they have thousands of tapes in them, and they take up big parts of the room. They're quite exciting to watch from a mechanical perspective. And they've filled up their tape silo. Great, no problem. They bought the model that you could extend. No worries. They rang up the sales rep, said, Mr. Sales Rep, would like an extension of the tape silo, please. I said, no problem, we'll order it. Purchase order went through, everyone was happy. I'm sure the rep was spending his bonus somewhere exotic. And the hardware engineer rang up once the equipment had been delivered and said, we've got a bit of a problem, we can't deploy this here. And they said, well, why can't you deploy it here? So unless the customers are willing to demolish this wall here, it just won't fit. So often we're stuck from a space perspective. In other times, we have horsepower problems. We don't have enough processing grunt to do the job we want. And I come across this a lot with a lot of customers in Australia, where they've got end-of-month processing, end-of-year processing. Marketing campaigns are an absolute doozy for this one, where I don't have enough horsepower to do what I need to do, and I will break. And we heard in the keynote this morning, great story about the Moomba example, where the website went down, unfortunately, because there was not enough horsepower. But the biggest problem, and this is the one that keeps the CEO up at night, is the lack of the ability to try new ideas. In most organisations, there's a huge amount of white space of just things that have not been tried because they're too expensive and the risk of failure is too high. And you'll hear this talked about quite often. I think it's a very valid point, is if you reduce the cost of failure, you increase the likelihood of people trying things out. It is a very different conversation going to your boss and saying, boss, can I have $500,000 for some infrastructure to try a project that may or may not work? As against having a conversation saying, boss, can I have $500 to try a project that may or may not work? You get a lot more opportunity at a lot lower cost, which means you can try. And if it doesn't work, you're not left with the infrastructure that is there that you needed to have, that is now useless for everything else. So one of the challenges is if we're looking at things in a conventional lens, if all we have is a hammer, everything looks like a nail. But fortunately, we don't live in that world anymore. We have the cloud, and we have this big toolbox that is available to us. So what if I said that you could extend your existing data centre into the cloud easily and securely? Well, hopefully you'd say, that's interesting, Simon. Please tell me more. So the short answer is you can. You can do this by connecting your existing data centre into the AWS cloud using a technology called Virtual Private Cloud. You can also choose the manner and style of connectivity between your existing data centre or data centres and your virtual private cloud or virtual private clouds. I'll talk a bit about this in detail shortly. But first, what I want to do is share with you 4 different modes of why and how you would do this. Now, this is not the exhaustive list, but this is a fairly representative list of the kinds of things we see customers trying to do. We see customers who have the island, the isolated project. We see customers who are sort of living in the bubble and just want to expand the internal sites out a little bit more, have a bit more space. We see customers who want to present themselves to the world, but use infrastructure and resource not of their own. And we, of course, have the much unloved branch office environment as well, which all of us struggle with. So let's look at those in a little bit of detail. The isolated project is a great one. This is a great example of stuff you need to do quickly that may have an interesting chance of success or failure. It may be a transient thing. We're doing something for compliance purposes, or someone got an idea they want to try out some new software. We need an environment to play in. Now, this is often hard to get. And often I talk to customers that say, look, we just need a Windows lab. We need 30 machines. That's all I need. And I say, great. I'll show you in 10 minutes how you do that, and I'll be on my way. And that's what they do. Whereas in a conventional environment, it can be challenging. I had a customer once who built an entire iPad application, full high bandwidth backend, MongoDB up the wazoo. They had built this beautiful thing, but they weren't sure if they were going to release it. So they spent 6 months building this application. Big development team, built the whole thing, intentionally saying, if we're not happy with this product, we will not release it. And it was okay. Because when they decided not to release it, they turned off all the infrastructure that they were running in their virtual private cloud and walked away. And they couldn't do that conventionally. So it gave them a lot of options in terms of that fast fail project. But this is useful where you don't need to talk back to anything existing. You're just doing your own thing, you're in your own world. More often than not, you want to expand an existing system into the cloud, either part of that system or all of that system. So in this particular model, we can do that. We can extend using our virtual private network into our virtual private cloud. We can choose not to expose any of our resources that are running in the Amazon virtual private cloud to the internet. Traffic can only traverse my virtual private network back into my own network, and that's the only way it can be accessed. So this is really useful for doing dev test. You know, I do dev test maybe once every 3 months. I need to do a whole test run. I need to scale up. I want to do something, then I want to go away. Really simple. Or maybe I want to do some disaster recovery. Or maybe I want to move entire corporate systems across into this environment. I have a customer who moved all their SharePoint, all their content management system, all their internal HR systems to the cloud because they just didn't want to manage the on-premise infrastructure anymore. They didn't want to put it on the internet. They just wanted to have it in their own virtual private cloud. So this is a very effective model for that type of work. The benefit here as well is you can use existing management tools. So if you're using different patch rollout mechanisms or monitoring tools, etc., the rules are the same. And I'll show you how that works shortly. Then you can choose to present the resources that you have in your virtual private cloud out to a broader community. So this is a really useful pattern when you've got internal systems, maybe it's order management systems or inventory systems or other type of order taking systems, but you want your web front end, maybe your marketing campaign to be really elastic. So you can have that public-facing component visible to the internet, visible to users, visible to partners. But the communication from that tier back is all done privately and is done to your existing resource. So this is a very blended and effective approach. Because we know you're not going to say and just lift everything you've got and move it in one fell swoop. You're going to have a combination of things over time. This allows for that. And then, as I mentioned, we have our much-loved branch office scenario. Often the problem child for IT because there's never enough money or resource. There's often low bandwidth between those sites. You can interconnect multiple sites into a virtual private cloud. They can share the resource. They can even inter-network between sites seamlessly. So this allows you to give branch offices access to way more compute and storage than they would have had previously. It's really useful for collaboration between geographically dispersed teams. One of the trends I'm seeing is a situation where software development in Australia is being done both onshore and offshore. So a team in Melbourne, a team in China, a team in Sydney, a team in the Philippines, for example. They can all collaborate and use the same infrastructure. So how do we make this connection? How do we put all of this together? So we use this thing called the virtual private cloud. And put simply, the virtual private cloud lets you create your own private IP address space on top of Amazon Web Services. You get to choose whether you want private addressing, public addressing, a combination of the two. You choose how data is ingressed or egressed from the environment. You set all those rules. And the nice thing is that the concepts and ideas encapsulated in virtual private cloud are very familiar to people who are very au fait with traditional networking technologies. Subnets, access control lists, virtual private network, order off a duck's back for a networking person, they all exist here. So how does this look? How do we put this together? So if we think about our existing environment, our existing data centre, we can choose a region. For the sake of argument, let's choose Sydney. How's that? Yeah? Finally, I can say it. Let's choose Sydney. And in our Sydney region, we can create a virtual private cloud across multiple availability zones. You've heard us talk about these availability zones. Use them. Always deploy across multiple availability zones. Your virtual private cloud spans availability zones and has virtual routing that allows you to set the rules that you want in terms of where traffic goes. You have total control over this. You can then connect back into your on-premise environment using a virtual private network into a router device. This is a hardware device, or it can be a software device. It can even be a Windows 2008 R2 server if you want it to be. The nice thing is it can use border gateway protocol or static routing, which is a new innovation that happened just a couple of months ago, which essentially means more devices support this methodology. What we then do is create different subnets within our virtual private cloud. They can be private, which means I can only route traffic internally in my internal network, or public, which means I can route traffic out to the internet. I then create my instances within those subnets like I normally would, and I can optionally have an internet gateway that allows traffic to egress out to the internet if I so choose for those subnets that I determine are allowed to do so. In addition, I can connect multiple branch offices into this environment if I want to. I can also access all my other resources as well, so all the familiar services within Amazon are accessible to you. And I can also use this thing called DirectConnect, and I'll talk about this in more detail shortly, but think of it as a dedicated line between your site and Amazon. So what do I get for my virtual private cloud? Well, firstly, each virtual private cloud gives you a user-defined address space of over 65,000 addresses. So if you're going to run out of addresses, I really want to talk to you, because I'd love to talk to you about that. But essentially what this means is that you get to set your own IP address range, which means it is compatible with your internal naming standards and your internal network management. These are your addresses, they are private addresses, which also means they're, by default, non-routable to the internet. You can create multiple subnets. 20 is just the base limit. You can have way more than that. But again, you can choose how big they are, depending on the use case and what you're trying to achieve with them. You get to define your routing, your DHCP servers, you get to define access control lists, etc. And I'll show you some of that shortly. The IP addresses that your instances get when you create an instance are stable once they're assigned. What does that mean? This means that when you stop and restart an instance, it retains the same IP address throughout the lifetime and life cycle of the instance. This is really useful for management tools that aren't cloud friendly, that aren't used to instances coming and going and changing addresses all the time. That doesn't happen in virtual private cloud. If your server comes up as 10.1.2.3 and you stop it and you start it again, it will be 10.1.2.3 all the time, which is really handy. We also support these funky things called elastic network interfaces, or ENIs. And this allows you to separate the life cycle of the network interface of an instance from the instance itself. So suddenly we've broken apart these two components and they can live independent of one another. And I'll share with you some ideas of what you can do with that shortly. So again, what this world means is that when you're launching your instances into the environment, instead of launching into a kind of flat environment here where you're kind of sharing the address space with other customers, we're launching our own instances. And when those instances come up, they come up with just the addresses that I set within my virtual private cloud. And they're all internal addresses. So I control what happens at the networking layer. Now I have access to a lot of rich things in virtual private cloud. So obviously I've got EC2, the Elastic Compute Cloud, and I've got EBS, the Elastic Block Store for compute and storage. But I have my load balancer. Not only do I have my public-facing load balancer, I have an internal load balancer service I can use as well. So I can have load balancing between my customers and my web tier, and then I can have a load balancer between my web tier and my app tier. Kind of handy, kind of helps you build for failure. I can also do auto-scaling, I can do CloudWatch like we saw Daniel do just before. So all these technologies are available to you. I can launch my relational database service. So I can have a managed MySQL, Oracle or SQL Server database running within the confines of my VPC. I can also do cool things like spin up Elastic MapReduce, which is essentially a hosted Hadoop service that allows you to do massive amounts of big data processing without having to buy any infrastructure. It's a very powerful service encapsulated, again, in this environment. So you control the naming, you control the traffic. We can do other things like cloud formation, which I'll show you shortly, cluster compute instances in regions where it's supported, and lots of others. So we talked about connecting a little bit. I want to expand upon that. So the primary way that people connect to their virtual private cloud is using a VPN, a virtual private network. This is an encrypted IPsec tunnel between your site and our site. Now, I didn't mention before, but the cost of a VPC is zero. It's personally my favourite cost. I like it when our customers don't have to pay anything for anything. But to set up a VPC costs you nothing. Obviously, the resources you run within the VPC incur a cost. And if you choose to have a VPN connection, a hardware VPN connection, you'll pay 5 cents an hour, basically $36 a month. That's kind of change if you think about it. And as I mentioned, we support both BGP and no BGP, which means that in all likelihood, the routers you already have in your environment would support this method of connectivity. You set it up yourself, you set it up via the console. When you jump into the console, you choose the type of router you've got, how you want to connect, it gives you the credentials, your network person loads that into the router, and you're good to go. It's a very straightforward configuration process. Does not require human beings, which is really important to get things done very quickly. Also, just out of interest, when you connect a connection to us, we actually run 2 tunnels to 2 different hardware devices. This means that you're able to have failover between those devices if we're doing maintenance and other things. So I mentioned before DirectConnect. What is DirectConnect? DirectConnect allows you to have dedicated bandwidth between your site and AWS. So if you don't like that internet thing, don't want to have anything to do with it, that's no problem. You can choose to have increments of 1 gig, 10 gig, and have those connections running between your site and ours. Now, this is useful in cases where you have a requirement for really low latency or a controlled latency experience because you have that service committed to you, or you want really high amounts of bandwidth. So if you're moving large amounts of data to internal systems, this becomes a really compelling option. Doesn't matter which carrier you're with, you can work with any carrier you like. Go talk to the guys at the Equinix stand. They'll talk to you about exactly how to get this set up because we work through partners to make this happen. Use VLAN tagging to manage the connections between the sites. So if you want to have a connection that hosts some of the public information to maybe S3, you can do that as well as having connectivity over your VPN. So you have a lot of richness and a lot of choice in how you deploy this. You don't have to use DirectConnect to use your VPC. It is an interesting option available to you. Another option that's there is something called dedicated instances. Now, this is a really interesting one because this says that I don't want to share with anyone else. When I spin up my EC2 instances, I want them to run on my own hardware in the AWS environment. I don't want to have anyone else being tenanted with me. So you can do this. It's an option. You can do it for all your instances or just a few. Yes, it costs more. Makes sense that it would cost more because it's kind of restricting that sharing ability, but it may be suitable for some use cases. Do you need this to be PCI compliant? No. This is for other use cases where you need to have some sort of non-multi-tenant environment. It is only available to you in VPC. So let me give you a customer example. New York Times, they do a little bit of business, a few million impressions and users coming through all the time there. And they had a really interesting growth experience. So they were running multiple data centres. And you can see there in 2009, it was less than 5% that they were using Amazon EC2, the Elastic Compute Cloud, for their compute needs. As you can see, year 2011, they're running 40%. But you know what? In my mind, that's not the good news story. That's just a story of, well, I'm using EC2. Great. What's so exciting about that? Well, what's interesting, oops, there we go, is that the Amazon component only contributed just under 26% of the cost. So if I net this out for you, 40% of the capacity, 26% of the cost. That means they're getting more capacity for less investment. It makes sense for them to extend into AWS and use that resource effectively compared to their on-premise environment. So I've talked enough about what you could do, what you should do. The proof is in the pudding. So what we're going to do here is I'm going to show you how you can create a VPC in less than 90 seconds. So in the old phrase is, let's roll the videotape, we'll roll the videotape. So here you can see me in the wizard, I'm in the GUI here, and I can choose from some templated options. I could do it custom if I wanted to. And you can see here I'm setting up my IP address range, I've got my public subnet, private subnet. These are just 2 being created, I could create lots more. I've got a NAT instance as well, and I click OK. Now just for reference, I did this sitting in a boardroom in our offices in Singapore, talking to our US West 2 environment in Oregon. So you can kind of do this stuff anywhere you like. So you'll be happy to know we do have the progress bar that stays on the last bit for longer, because that's always important with the progress bar. It should never go all the way through. It needs to pause a little bit. So this is real time. I didn't want to speed this up for you. I thought, you know, how hard is it to create a VPC? Well, let's do one. Well, it's done. That wasn't so painful, was it? So what have I got? I've got a virtual private cloud. There it is there. I've got some subnets that I created automatically, which will pop up in a moment. Ding. I've got this one here, which is, from memory, a public subnet, because it routes traffic internally and anything else out to the internet gateway. So it can talk to the internet and receive traffic from the internet. And here I have my private one, which I've set up to say, keep everything internal, but if I need to call out to the internet, I can do that through this instance, which is a NAT instance doing network address translation. So if I want to call external services, I can. It wasn't particularly hard, was it, to create a VPC? In fact, it took a lot less than it took me to tell you about it. But let's do something a little bit more fancy. Let's build a VPC and have an instance in it and put some software on it and do it in the most lazy way possible, because I come from a software development background, and the good software developers are the lazy software developers. And when I say lazy, I mean they want the biggest outcome for the least amount of effort, which is a good thing. So let's roll the videotape and we'll have a look at how we do this. So what we're going to do here is we're going to use this thing called CloudFormation. CloudFormation allows you to create these things called stacks, which are based upon a template, a pre-written template of what you want to build. So in this case, I'm using a stack that will create me a VPC with an instance, and it'll install PHP and Apache and a few other services on there for me. I've got a template URL, which is just living in S3, can live anywhere you like. And in this case, I just need to give it my credentials and the size of instance that I'd like to create for this particular situation. So once I get my typing right, we kick him off and we start him. Go. So what happens then is it starts doing all the work that I need to do. So let me take you through what it's doing. So you see it's kicked off, and we'll go and look at the template. So the template is JSON formatted, and basically it's this human readable thing of saying, well, here's the resources I want to create, subnets, the details about the gateways that I'm creating, all the security requirements I need to set up can all be encapsulated in there. What else have we got here? We've got the IP address that I'm going to have for the server, the security group that I need to have, my keys. Here I'm saying I want to install Apache, I want to install PHP as well. Here's some code I'm actually putting on there. I'm setting the group and the owner so it'll run, etc. So I'm doing a whole lot of stuff here and making sure my services are running as well. Pardon me. A whole lot of stuff here that is work that you normally have to do that you can encapsulate in this particular template. So what we're going to do now is I've kicked off that template, and truth be told, I had a cup of tea after I kicked off that template, and I came back. So let's roll the videotape and we'll see what happened as a result. So my create was complete, and I can see all the resources that I created. I created VPCs and subnets and internet gateways. I was very excited with all the work that I did. I can see when they took place and what happened. Everything is named independently, so it doesn't clash with anything else. Pardon me. And I can see my IP address of where I need to go. There's my server running my sample application. But I can also go and check what I built. So I'll just go and make sure I've got my VPC that I built out of this template. And there he is. Internet gateway, route tables, the whole shebang. Can I have a glass of water, please? And you'll see here we're going to look at the instance that I ran. So there's my running instance. There he is. And we can see here that he lives in the VPC.
And he's also tagged with that fact as well, as I quietly joke. And we can also log on. Thanks, Peter. That's better. Pardon me. Alrighty. So we can see here I can log on to my instance. I'm losing my voice, aren't I? It's great. We'll get there. I can log on to my instance, it's running software, it's doing good stuff. Pardon me. I feel like a ventriloquist. So, I think you'll agree that despite my coughing, we built lots of stuff there really easily and really quickly in real time. So you can be as sophisticated as you like, you can be as technical as you like, you can create this type of topology. This is an example of SharePoint in the cloud. Here we've got multiple subnets, we've got a web tier, we've got an application tier, we've got Active Directory. We're syncing back to our on-premise AD. There's a white paper that has all this for you. Better than that, we have a set of 6 CloudFormation templates that will build this for you. Pretty cool. So what else about some interesting technical stuff? So I mentioned the elastic network interfaces. Pardon me. These are really useful if you want to disassociate your instance from the network layer. This means the instance can have multiple network interfaces. They can be in different subnets simultaneously. This is useful for creating things like management networks, etc. You can even use it for HA, failing over between instances if you want to. Or if you have software that needs to be licensed by the MAC address, this is a great way to do it as well. It also allows you to do multiple IPs per elastic network interface. This has been something people have asked for a long time. You can only do this in VPC. You can have up to 30 IP addresses per ENI, and depending on the size of the instance, you can have up to 8 of those. So that's a lot of instance IP addresses as well. Also, things you can do, you can create DHCP option sets. So you can give your own domain name for the servers, you can give your own time services as well, so you can make it like your internal environment would look like anyway. And there's a whole bunch more technical stuff that I won't get into right now. Excuse me. So people often talk about migrating to the cloud because I want all these goodies. I want the lack of upfront investment. I want the flexibility. I want all the cool stuff. And I want it more because it's what the cool kids are doing. I want to do something meaningful and useful. So you need a cloud strategy. You need to understand why you're doing this and which applications are suitable to do this. Now, obviously, if you're building something new, it should be a cloud-ready design. It should just work in the cloud when you make it work. Because you get a whole bunch of benefits. You can take advantage of the elasticity when you need it. You can do migrations when you need it. I want to give a bit of a shout out to NYOB. We've got a few members of a few different teams in NYOB in the room today. A couple of the guys here flew up from Melbourne this morning, and during one of the earlier sessions, they spun up their entire application stack in the Sydney region in about 40 minutes on their laptop on a 3G connection. I challenge you to find an easier migration than that in any other IT environment. That's pretty cool. So that's what you can do if you build a cloud-ready design. Now, for your existing applications, it's not always so easy. So there are 2 kinds of categories. The ones that are kind of no-brainers, we'll talk about what those are, and there are the ones that are going to take a planned and phased migration. And these migrations typically take place when we're doing upgrades of hardware, new code releases, or we're choosing a completely new product to deliver the capability within the organisation. So what are some of the no-brainers? Well, dev test, absolute no-brainer. I've never met a customer who said, I have all the development and test resource I need. I can stress test as much as I want. I've got lots of servers for devs. It's Clover. We're in a fantastic position here. It never happens. So this type of topology lets you build out that environment really effectively and easily. Self-contained web applications are really good as well. I had a customer who wanted to trial some new survey application for their internal users. They're a very large organisation. They wanted to survey their employees. Traditionally, it would be very difficult to build up this infrastructure and get it running because they're only going to run the survey for a few weeks. They just spun it up and got rid of it. If you're just trying something out, another customer who was assessing Drupal as a content management system. I want to think, what's this going to be like? So they thought, well, let's not look at the brochures and the reviews. Let's just spin it up and use it for a bit and see what it's like. It cost them like $20 to do it. It was not an expensive process to do for the security of knowing what you're doing is the right way to go. Another great one is any social media or product marketing or campaign type application. That by definition needs to be elastic. That's the stuff that breaks and is high profile when it breaks. You can deploy all that stuff in a virtual private cloud, present it to the internet, allow customers to use it, and still talk back to internal systems that may be gathering that data, processing that data, doing order entry, etc. Think about the topology options that are available to you. Demonstrations are another great one. It's amazing how many times showing something is better than talking about something. And SAP is a great example of this. They use AWS to demonstrate their product because they can spin up large environments, they can do labs, they can help their customers see what their product does in reality. Another great model is software deployment. How do you push software out to your users? Let's say you've got a big ISO file that you need to push out on a regular basis. Well, if you're not using some sort of content distribution network, you're doing it the hard way. Throw it into CloudFront, push it out to your users. Life is a lot easier. You're not managing FTP servers and everything else. So lots of options there. For the more complicated ones, we do have this migration white paper that I commend to you amongst a whole lot of collection of different white papers that we have that takes you through a phased process where you assess the dependencies in your environment. You understand which elements make sense. You do a proof of concept. Try these things out. One of the beauties of this type of platform where you can just sit at your laptop and do stuff is you can try things. See how it really works. Don't take my word for anything. Try it yourself. See if it works in a way that suits you. Then migrate your data, migrate your applications, leverage the cloud in terms of its capabilities, and then optimize for price. We talk a lot in the technical track about optimizing for performance and for elasticity and for availability. We can do all those things. One of the other things you as architects can do in the cloud is optimize for price. And it's a really exciting concept. And I can guarantee you the business would love to talk to you about that because that's always interesting to people. So in closing, the virtual private cloud and VPN and DirectConnect give you a bridge to the IT capabilities that your business needs. I guarantee you if you go back to your organisation today, you will find projects that are not going ahead because there's not enough resource available to you. Right now, in Sydney, in Australia, there is that resource available to you, and I think it's really exciting. Now, in closing, I would not do myself any good if I didn't do a bit of self-promotion, so I'll do that for both the people in the room and online, which is I just wanted to point your attention to the AWS podcast that we have. My colleague Simone Elisha and I do this on a pretty regular basis to try and get one out every week. It's a good way to keep up to date with what's going on in AWS land. We give a few examples of what we can do, different services, updates, etc. So if you're that way inclined, love to have you as a listener as well. So with that, I'm going to close and invite Peter back up. Thank you.